4.2 day 1, we are going to be working with amplitude and periods. So today we're going to look over how to identify the amplitude and the period of a graph of an equation. So when we're looking at an equation, whether it's sine or cosine, we are going to have the standard form of y equals a times the sine of bx, or y equals a times the cosine of bx. This a value in the front is going to be our amplitude. So before, when we graphed our regular sine cosine function, our maximum value was 1 and our minimum was -1. So today we're going to graph, and we're going to start by graphing our parent graph. So for this one, because it's sine, we're going to graph just y equals the sine of x. And we're always going to want to graph one full period, which is why it goes between 0 and 2 pi. So on my axes, I'm going to label 2 pi, cut that in half, that's going to be pi, in half again, pi over 2, which would make this one 3 pi over 2. And remember, we get all of these values from our unit circle from those points that are on the axes. So we have the point 1, 0, 0, 1, -1, 0, and 0, -1. Each coordinate point, again, is cosine and then sine. So for this one, we're looking at all of the y values for our sine value. And going around, we start at 0, pi over 2, pi, 3 pi over 2, and then we go around back to 2 pi. So looking for the sine of 0, it's going to be 0. Then the sine of pi over 2, you go to the pi over 2 on our unit circle, look at the y value, which is going to be 1. And I forgot to label that on my graph. 1 and -1. And then the sine of pi, you go to pi, and the sine of that would be 0. The sine of 3 pi over 2 is -1, and the sine of 2 pi is 0. So this would be our parent function. And remember, because this isn't part of our final graph, this is going to be a dashed line. There we go. And then step 2 for our graphs is we are going to do any transformations. So that means if our period changes, we're going to do that, or our amplitude. So looking at our equation on this one, we'll notice that there is a 2 in the front, which means we're going to take all of our y values and we're going to multiply them by 2 for our parent function. So our first point was at 0, 0, and 0 times 2 is still going to be 0. Then we have the point pi over 2, 1. And 1 times 2 is going to be 2. And then it goes 0 again. -1 times 2 is -2. And 0 times 2 is 0 still. So you'll notice our parent graph only went up to 1, but now our actual graph is going to go all the way up to 2 and then down to -2. And that's because our amplitude in our equation was changed from 1 to 2. So when just our amplitude is changed, our graph is going to be getting taller or shorter if it's a fraction. Alright, so let's move on to example 2. We're going to start out with the same steps. So step 1, we're going to do the parent graph. And this one's cosine. The period of cosine is the same as sine. So we're going to go from 0 to 2 pi again. Then we can label them on our axes. Remember, you do need to have these main points labeled on here. All right, so starting with our parent graph, we're still going to be using those points from our unit circle. And remember, cosine is now going to be our x-coordinate point. So instead of using the y, we're using the x. And if you just want to draw it once and then reuse the same one each time, that is okay. So now we're using these x values to graph our parent graph. So our cosine of 0 is going to be 1. Cosine of pi over 2 is going to be 0. Cosine of pi, -1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1 again. And if you want to get a full cycle, you can add in -pi over 2 over here, and that would also be 0. So now we have our parent graph. Draw this in there. Perfect. Okay. Once you have your parent graph, then step 2 is to go ahead and do any transformations. So for this one, if you look at our equation, we have y equals 1/2 cosine of x. So this tells us that our amplitude is going to be 1/2. So we're taking all of those y-coordinate points and multiplying them by 1/2. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. Oops. 0 times 1/2 is 0. -1 times 1/2 is -1/2. So add that there. 0 times 1/2 is 0. And 1 times 1/2 is 1/2. So you'll notice whenever we have a fraction for our amplitude, if it's less than 1, our graph is going to be getting shorter instead of taller. So a summary of what we just went over for amplitude is if a is a positive number, then the graphs of y equals a times the sine of x and y equals a times the cosine of x will have an amplitude of a. So remember, for these, you are going to start with the parent graph, and then you are going to change the amplitude. All right, so next on your own, try graphing 3 cosine of x and 1/4 sine of x on your own. And once you have those drawn, you can press play and compare your graph to the 2 drawn here. Okay, so you should have started by drawing your axes. Okay, and I'm going to start with the 3 cosine of x. And we're going all the way up to 2 pi. So make sure you labeled your axes. And you started with your parent graph. And once you do this a few times, that parent graph is just going to come secondhand to you, and you won't even need to use that unit circle to get this parent graph drawn. All right, so our first one, we did 3 cosine of x, which means our amplitude here was equal to 3. So all of these values are going to be multiplied by 3. So it should go up to positive 3 and then all the way down to -3 on your graph. So this one should have become a longer value or a longer graph, so it was taller and it went down a lot lower. Then looking at our sine graph, it was still going to 2 pi. So again, we'll label our axes. And 1, -1. Okay. So for this one, we're going to again start with our parent graph. And sine always starts at 0, goes up to 1, goes to 0, down to -1, and then back to 0. And because this is a parent graph, not part of our final answer, it's going to be a dashed line. And for this one, you'll notice that we have y equals 1/4 sine of x, so our amplitude is 1/4. So 1/4 of 1 is going to be down to 1/4, 0, -1/4, and 0. So this graph is significantly shorter than the parent graph because our amplitude was less than 1. Right. So compare your answers, and then once you have the correct graphs, you can go ahead and press play. All right. Our next one, we are going to be graphing y equals the sine of 2x from 0 to 2 pi. And we're going to go on the intervals of pi over 4. We are going to skip filling out the table today. And I'm just going to show you how to do the graph part. So let me see, maybe I can just delete it from here. Oops. Sorry, one second. Just trying to see if I can delete this table. There we go. And you can just cross it off on the paper notes. This is just going to save us some time by not having to do that. Okay, perfect. So we're going to graph this on the interval of pi over 4. So before we talked about the amplitude, and that was the value that was in front of our functions. Now we're going to be talking about our period of the graph. So we know that A represents our amplitude. Now our period, we are going to be using this B value here. So that is only part of the period. So when you find the period of a graph for sine and cosine, your period is going to be equal to 2 pi over the B value. And that's going to be the length of your period. So before, on our parent graphs, where we had y equals the sine of x, the number in front of the period was just 1. So when we would calculate the period of that graph, it would be 2 pi over 1, which just equals 2 pi. So now if we look at this example here, we have a 2 there. So when we calculate our period of this graph, it's going to be 2 pi over 2, which equals pi. So once we've calculated our period, we can go ahead and graph. So we're going from 0 to 2 pi again. Let's go ahead and draw that on here. Oop. So we have 2 pi, half of that is pi. Oh, that wasn't really in the middle. I'll adjust that really quick. Pi, and then pi over 2, and 3 pi over 2. And our amplitude is 1 for this because there's no number in front, so that's our amplitude. So we can go ahead and graph our parent function for our sine graph. Down to -1 and 0. We'll graph that on there. Okay, so our amplitude is not changing on this, but our period is. So if you look at our parent graph, we take a full cycle from 0 to 2 pi. Now, because our period is equal to pi, our full cycle is only going to be going in between those two. So we're going to, again, start at 0, 0, and we're going to end our full cycle at pi. So that means we have to have a maximum and a minimum in between those values. And if you look at our parent function, you'll notice halfway in the middle, we're at 0. So again, halfway in the middle of this period, we're going to be at 0 again. So for this, we're just going to have to add in a few extra units on our x-axis. So we're going to do pi over 4 and 3 pi over 4. At those points in between the zeros, that's where our new maximum is going to be. Oh, I want that to be red. So we've got our maximum now, and then we have to also do the minimum point. So our graph is going to go like this. And we have a full period. And then we're just going to continue that pattern moving on. We have to go up 1, down to 0, down 1. Oh, that's in the wrong spot. Down to -1, and then back up to 0. And there is our new graph. And this one has a period of pi. And because it has a period of pi, we have 2 full cycles between 0 and 2 pi. One cycle is highlighted in yellow, and then the second cycle is highlighted in purple. So we get 2 full cycles there. Okay, so if you need to, pause the video so you can get the rest of this graph drawn, and then we'll move on to the next one. Okay, so I'm just going to delete this table again. You can cross yours off, or you can delete it as well if you would like. There we go, almost there. Boom, gone. Alright, so now this one, we are going to graph y equals the sine of 3x from 0 to 2 pi again. So again, if we have y equals a times the sine of 3x, oh, so sorry, this one is just no number in the front. This means our amplitude is equal to 1. And then the part of our period is 3. It's going to be there. So sometimes when our period is a weird value, so for this one, if we calculate our period, it's going to be 2 pi over 3. And thirds aren't even on our original graph for our parent graph. So when that happens, I recommend skipping the parent graph and just going ahead and graphing your new period. So we know we are going to go to 2 pi over 3. So we are going to have a full cycle between 0 and 2 pi over 3. And we just need to keep adding on enough space for us to get all the way up past 2 pi. So we have 2 pi over 3, 4 pi over 3, and I'm going to have to make this a little bit longer. Pen's not working. There we go. So we have 2, 4, and then the next one would be 6 pi over 3, which simplifies to 2 pi. So first I recommend putting those labels on our graph because those are going to help us get our periods that we need. So if we break those in half, 2 pi over 3 in half would be just pi over 3, and then we can cut those sections in half again. So we have pi over 3, 2 pi over 3, 3 pi over 3 would be pi, and cut those in half again. So we have, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So the next one would be 5 pi over 3, and cut those in half. And then we go all the way up, you'll notice, to 2 pi. Now that we have those, we can start by filling in our graph then. And our amplitude is 1, so we're still going up to just 1 and -1. So we're going to start at 0, 0. And we are going to have a full cycle between 0 and 2 pi over 3, because that's what our period is. So we are going to go to the middle of that, which is pi over 3, and that's where 0 is going to be again. And we're going to do our maximum, and then we're going to do our minimum. So right now we have one full cycle of our graph between 0 and 2 pi over 3. Then, we will just continue this pattern. So from 2 pi over 3 to 4 pi over 3, we're going to have another period. So in the middle of that, we're going to be at 0 again, and we're going to go up to 1, and then go down to 1, because we're still following this pattern throughout our graph. And then our next section, again, between 2 pi over 3 and 2 pi. In the middle of that, we're going to be at 0 again. And then we're going to go up and then down. So this is what happens when your period changes. And whenever you get a weird number like 3 on the bottom, it might be hard for you to do your parent graph first. If you want to add your parent graph on there, we know the parent graph is going to be between 0 and 2 pi for one cycle. So 0, 2 pi. Halfway is pi, which is 0 again. Half of that would be here, so we have to go up to 1. And halfway will be down to -1. So this is what it looks like in comparison to our parent graph. There you go. So if you were to label all of the parts on the x-axis, this one would be pi over 6. So each mark goes up 1 pi over 6. So that would be 1, 2, 3 pi over 6 is just pi over 2. 4, 5 pi over 6. 6 pi over 6 is pi. And then we would do 7 pi over 6. 8, 9 pi over 6, which we can simplify to 3 pi. 9 pi over 6. It would be 3 pi over 2, 3 pi over 2. So 9, then we go to 10, and then 11 pi over 6. So if you were to label all of them, that's what it would look like. That does get a little crowded on the paper though. So if you just label the key ones where you have the pi over 3, 2 pi over 3, where it equals 0 and crosses the x-axis, that's okay. So if you need a moment, pause the video so you can finish drawing your graph, and then we will move on to the next one. All right. So example 6, this one we're going to graph one complete cycle of y equals cosine of 1/2 x. So same thing as for sine. The period of cosine is going to be 2 pi over b for our period. So for this graph, our b value is 1/2. So our period is 2 pi over 1/2. So that's the same thing as taking 2 pi times 2, because you multiply by the reciprocal. So we're going to have a full period in 4 pi instead of 2 pi. So whenever your b value is a fraction like that, less than 1, your period is actually going to be getting longer. So it's going to be spread out more. So we're going to go all the way up to 4 pi. Half of that would be 2 pi. Half of 2 pi is pi. And that would mean this would be 3 pi. So if we were to graph our parent function, go to 1 and -1, our parent function would start at 0, 1 for cosine, and then it would end at 1 at 2 pi. So we go up from 1 down to 0, to -1, 1, up to 1. So this is what our parent graph will look like. And we'll notice between 0, oh, sorry, this is supposed to be a dashed line. Between 0 and 4 pi, we are going to make 2 cycles. Because it's twice as long as our normal period. So then, we are going to be stretching our graph out, because we're only going to have one period between 0 and 4 pi. So we know that it's going to start at 1 and it's going to end at 1. And if we look at our full period of our parent graph, if we start at 1, we go down to 0, and halfway through we're at -1, and then we work our way back up to 1. So we know halfway through of our full period of 4 pi, which is, we are going to be at -1. And halfway between the +1 and -1, we're going to be at 0, which would be pi. And then halfway again, we're going to be at 0 at 3 pi. So we're just following that same pattern. And we're just stretching that graph out, making it longer. So that's what the graph of y equals cosine of 1/2 x would look like. So our summary so far is if b is a positive number, then the graph of y equals a sine of bx and y equals a cosine of bx will have the amplitude of a, oh, it's not a highlighter, so our amplitude of a, and then our period of 2 pi over b. And this is for, again, sine and cosine. Now we're going to do an example of where we're going to do a graph with both the amplitude and the period changed. So we're going to skip example 7 and we're going to go ahead and just do example 8 and 9. So for this one, right away we should be able to identify that our amplitude is 4. And then our period is going to be 2 pi over our b value of 1/2, which we know from our last example equals 4 pi. And they want us to graph from -4 pi all the way up to +4 pi. So that means our graph is going to extend in both directions. We have 4 pi, half of that is 2 pi, pi, and 3 pi. 4 pi, 2 pi, 3 pi, and pi. And our amplitude is going to go all the way up to 4. So if you don't have room to put 4 dash marks, you can just put one line, just like normal, and then label it 4 and -4. If you want to make your graph look taller by adding 4 dash marks, you can do that as well. But as long as you label them with what the amplitude needs to be, it's not really necessary. So this one is our cosine, and we know cosine usually starts at 1, but because our amplitude is 4, cosine is going to start up at 4. And we know that we are going to end up at 4 as well. So following our pattern, we start at our maximum for cosine, and we work our way down to 0, then our minimum, back up to 0, and then to our maximum. So right there, we have one complete cycle of this graph, which just went from our maximum of 4 down to -4 and then back up. Then we follow the same pattern going the other direction. So we start at our maximum, go to 0, to our negative, back to 0, and up to our maximum again. And that would be the second half of this graph from -pi/4 to pi/4. If you want to add in your parent graph to this, you can, but it's not necessary as long as you can figure out these points without it. All right, so moving on to our next example. We're going to graph y equals 2 sine of pi x. So our amplitude for this one is going to be 2. So we're going to go up to 2 and down to -2. Our period is 2 pi over our b value, which this time is pi. And that's okay. It doesn't change the way we're going to do this graph. So the pi's just simplify, and we have an amplitude of 2. And we're going to go from -3 to 3. So we're going to draw our axes. And our period is going to go up to 2. So halfway of 2 is 1. And so far, I'm just going to start by graphing the part that is going to be on our period. So we're going to go from -2 to 2 to start with, and then we'll extend our graph for the domain they want. Our amplitude, we know we're going to go all the way up to 2 and then down to -2. So let's go ahead and start. We know sine starts at 0, so that's where it's going to start here. And then from there, we go up to our maximum, and then back down to 0, down to our minimum, and back up to 0. So this would be one full period of our graph. Then going in the opposite direction, we have our maximum to the right of this, and then we're at 0. So now we're going to go back down to our minimum, up to 0, up to our maximum, and back down to 0. So you'll see that we get another complete cycle here. And you want to make sure that in between the negative and the positive, you have one maximum and one negative. So you don't want two maximums right next to each other there. So you want to make sure that those are different directions. So now that we have our full periods drawn here, we're going to extend our graph to the domain that they want. So we're just going to continue on this pattern of adding in our units, which are going up by 1/2, and we're just going to extend that graph. So the green part goes to our maximum, down to our minimum to 0. So the next step is to go up to our maximum and back down to 0. So we're not going to draw another complete period, we're just going to draw part of it. And then on the other side, we're going to do the same thing. We go from our maximum to our minimum, from our maximum to 0. So we're going to go down to the minimum and back up to 0. So we're just extending that graph to fit the domain that they asked for. So that's what our complete graph will look like. So for today, go ahead and do the assignment. The answer key should be posted. And tomorrow, because I wasn't here, we'll go over any questions that you have. Have a good day.